Good day, students. We are now in topic 1, lesson 4, and we're going to be diving into transformations, how to represent them and describe them. So some of the key concepts that you'll be learning in transformations for this lesson is how to represent a transformation in the plane, how to describe a transformation's function, and also how to compare transformations, whether to see if they preserve distance or angles, and those that do not. So we're going to talk about how we manipulate figures within the coordinate plane, what happens when you move them, what is a pre-image and an image, what notation is going to be used when we transform. So these are all the things that we're going to be going over in this topic. Okay guys, let's go right into example number 1. It says find the unknown coordinates for each transformation and draw the image. Then complete the description of the transformation and compare the image to its pre-image. So here in the problem I have what we call a transformation rule. Pretty much what it means is that I take these points, X and Y, and I'm taking these points X and Y and plugging it into a function rule. So whatever I have for X is going into this rule, and it tells me the rule says that X is going to be subtracted by 4. And then I have Y is going to be plugged into the rule and tells me that Y is going to be subtracted by 3. So I have the points of my figure. I have points A, which tells me in the problem that it's 0, 4. I have point B, which is 3, 0, and I have point C, which is right at the origin of 0, 0. I'm going to take these points of my what we call pre-image, so let's make that a P, pre-image, and then I'm going to plug it into my rule, and it's going to spit out an output, and that output is going to be called the image. Okay, so let's walk through what they did first for A. So A, they plugged in 0, and 0 is our x coordinate, so 0 minus 4 gave us a negative 4. And then they plugged in our y coordinate, which is 4, so that's y for 4. So that's 4 minus 3, and that gave us a positive 1. So 4 minus 3 is 1. And then they gave us this coordinate point. They gave us this coordinate point A prime, which is going to be 4 units to the left, 1, 2, 3, 4, and then 1 unit up. So this is our point A prime. So this is our image point from our pre-image point A. So we know the difference between the two because our image point always has this little notation by it, which is called prime. All right, let's do the same thing for B. So B is here, which is 3, 0, and I'm going to do the same thing we did for A. For B, we're going to plug in our x point, which is 3. So 3 minus 4 gives us a negative 1. And then for our y coordinate, we have 0 minus 3, which is a negative 3. So now we're going to go ahead and plot our point for the B prime, or our image point. So negative 1 is 1 to the left, and then 3 down for negative 3. 1, 2, 3. So our B point, or our B prime, is here. And then last, we're going to do the same thing for C. So C is right at the origin, so we're going to do the same thing, plug in x. 0 minus 4 gives us negative 4, and we're going to plug in the y coordinate, so 0 minus 3 gives us a negative 3. And we're going to go ahead and plot that new image point for C. So that is 4 to the left and 3 down, 1, 2, 3. And our new point for C is here, which we call C prime. So now that we have our new image for ABC, we're going to call this our image. So that's now A prime, B prime, C prime. So now we're going to describe, because remember it says we have a description here. We're going to describe the transformation that just took place. So as you can see, this figure, the pre-image is now at the origin, and it has now moved over. Okay, it's moved over. If you remember from your warm-up activity, this type of transformation is called a translation. When we have a translation, that means that it's called a slide. Okay, so the pre-image performs some type of slide over to create our new image. But now we have to determine how many units did it slide. So we can do that by just focusing on one point. I'm going to focus on A. So it says, how many units did it move? It says 4 units to what direction? Did it move 4 units to the left or right? Well, here it shows me it moved 1, 2, 3, 4 units to the left first, right? And then 3 units, did it move up or down? So it shows me here in the picture, 1, 2, 3 units down. 4 units to the left and 3 units down. So if I compare the pre-image to the image, it shows that the figure is still the same. Okay? So nothing really changed but the location. The figure itself is still the same. And remember, if I still have a congruent figure, if the figures are still congruent after the transformation has been done, then we can call this what type of transformation? We can call this rigid motion. All right, let's look at example 2. It says use the coordinate notation to write the rule that maps each pre-image to its image. Then identify the transformation and confirm that it preserves length and angle measure. So let's look at this example. Here it tells us that we need to now write the rule for this transformation. In the previous example, they gave us the rule. Here we need to find out what that rule is. So what we're going to be using is some deductive reasoning, ladies and gentlemen. It may first start out as inductive because we're trying to look at a pattern, but because we are writing a rule, that means that rule has to work for every single point. So we're going to be using some deductive reasoning today. So the first thing I need to do is determine which figure in this coordinate plane is my pre-image and which one is my image. So I have my pre-image here of coordinates A, B, and C, and I have 1, 2 for A, 4, 2 for B, and 3, -2 for C. So I see here in the picture that this would be my pre-image, and we're going to label it with a P in the middle. And then I have my image point here with A prime at -2, 1, B prime at -2, 4, and C prime at 2, 3. So I'm going to label this I for my image. So please make sure, guys, when you're doing these problems, that you are identifying what your pre-image and what your image is and labeling those figures before proceeding. All right, so once again, we're going to look for a pattern. We're going to look for a pattern so we can go ahead and write that rule. So first, let's look at the x coordinates. Let's look at the x coordinates. So it says the x coordinate of each image, so that's here, -2, -2, and 2. We see that the x coordinate of each image point is the opposite. It is the opposite of the y coordinates in the pre-image. So here I got a -2 for my x, but I got a 2 over here for my y. I have a -2 here for my b prime, but I have a 2 here for my b. I have a 2 here for my c prime for x, but I have a -2 here for c for y. So we see that the x and y coordinates are opposite from the image to the pre-image. Let's look at another observation. So let's look at the y coordinates. So for the y coordinates, I see that each image point is equal to the x coordinate point of its image. So if I look at the y coordinate here, the y coordinate of my image A prime, I see that it's the same as my x coordinate here of my A in the pre-image. Same for B prime, I have 4 as y, and for B I have 4 as x. C prime I have 3 as y, and then C in my pre-image for x I have 3. So I see that the y coordinate is equal in the image point to the x coordinate of the pre-image point. So if I'm seeing that these two things are flipping, you may not know this information yet, but I'm going to tell you that if you see that the the points are flipping and they're equal from x to y, and you see that the x coordinates are opposite of the y coordinates from the image to the pre-image, then this is called a rotation. Okay, a rotation happens, and this type of rotation that's happening from the pre-image to the image is happening over a 90-degree angle, and we're going to get into that a little bit later, but I just want to let you know that there is a rotation that's happening from point to point. So B is rotating to B prime, A is rotating to A prime, and then C is rotating to C prime, all at 90 degrees. But what's most important is the rule, because remember, ladies and gentlemen, the question asks us to write a rule, right? So if I were to write a rule, that means I'm going to use the transformation function notation. So that means that I'm taking every point x and y and I'm going to put it in some type of function notation, right? I'm going to put it in some type of, think of a function machine. So what happens when I go from the pre-image to the image? What happens to my points? Well, we said that the x's become the opposite of the y's, right? So that means that they change. So that means I switch them around and they become negative. So that's going to be a negative y. And then my y's are now equal to my x's. Okay, so y is equal to x, and then my x's become opposite of my y. So that would be the function notation, ladies and gentlemen, of this particular transformation. And that transformation is a rotation. Okay, last example, guys. We have example 3, and it tells us to use the points h, which is -4, 1, and k, which is 4, 1. So in part A, it tells us to describe the segment HK and find its length. So first we have to plot the endpoints of this segment. So we have -4, 1 for H. So -4, 1 is here for H. And we have 4, 1 for K, which is here. So that is our segment, guys. So it tells us to describe the length of the segment. So, well, here I can just count the units from one endpoint to the next. So I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 units. So this is 8 units long, and it's a horizontal segment. Okay, so right now we're just describing what type of segment we have. Now it wants us to describe the image of segment HK under the transformation if we plug those points in and we get -y, x. So pretty much what we did last example, when we flip the coordinate points and the y becomes opposite. So what happens when we do that? Well, let's see. If I have H, right, my original pre-image point was -4, 1. If I plugged it in to that rule, my image point or new point, H prime, well, let's plug that in. So that means I'm switching my y's. So my y, my new x is going to be 1, and remember we're taking the opposite of it, so that's going to be -1, and then my new y is going to be -4. Okay, and we're doing the same thing with k. K is 4, 1. So my image k, same thing, our y in the pre-image is going to be now our new x opposite, so -1, and our new y is going to be our x, which is 4. Okay, so we're going to have -1, 4 for k prime. So if we want to go ahead and draw this out on our coordinate plane, we can with our new points. So h prime is -1, -4, so to the left 1 and down 4, so we're going to be here, and that's going to be h prime. And then we have k, which is -1, 4, so to the left 1 and up 4, so that's going to be here, and that's going to be our k prime. And then that's our new segment transformed under that notation. All right, let's go to the next part. C, describe the image of segment HK under the transformation. And now we have a new function rule of 2x, y. So we're going to take our original pre-image points, which is h, -4, 1, and k, which is 4, 1, and we're going to plug it into our function rule over there so I can get 2 new image points. So let's call this h double prime and K double prime so we don't confuse it with the part B. So if I plug this -4 into where my X is, that's going to give me 2 times -4. 2 times -4 gives me a -8. And then 1, we don't see any change here for the Y, so we just leave it as it is. That's going to be 1. Same thing again here for the 4. 2 times -4 gives me 8. And nothing changes with the Y, so that stays the same as 1. So if I wanted to go ahead and plot this, and let me go ahead and do that in a different color. We're going to plot -8. So -8 would be to the left. So let's just say -8 is around here. And that's going to be my H double prime. I'm sorry. And we need to go 1 up. I forgot my Y coordinate. So we go to the left, -8, and then 1 up. So that's going to be H double prime. Okay. And then we have K. So K means that I'm going to go to the right 8 and 1 up. So K is going to be somewhere around here, and that's K double prime. And as you can see, it actually extended our original or our pre-image line segment. Okay, so let's go into the comparison. If I wanted to compare the two, I can say first, the first transformation, so let's say the prime transformation, this one right here, was a rigid motion. So that was rigid motion for the first transformation, right? And then for the second transformation, the double prime was non-rigid. Okay, so remember, rigid motion means it preserves the size. So if I look at my my H double prime and my K double prime, all it did was extended. And if I extended it, that means it's non-rigid. But if I look at my H prime and my K prime, yeah, it turned it, but it didn't change the amount of units it was. So if you look, it's still the same amount of units, 1, 2, 3, 4, 5, 6, 7, 8. The units did not change from HK. It's still 8 units, all right? So in the rigid motion, it is still 8 units. In the non-rigid motion, it extended. So we went from -8 to -8. So that makes it double the amount to now 16 units, all right? And that's right now, those are the only two comparisons that we can make. We can say that the first transformation was rigid. It didn't change anything. Everything remained the same for the exception of the position. However, the second transformation was non-rigid, meaning that it did not preserve the length or the distance between the two segments. As you can see, it doubled in length, so it was 2 times the length that it doubled. So we can know for sure that that is not a rigid transformation. Okay, ladies and gentlemen, that concludes our lesson for today. If you haven't done so already, please make sure that you are completing the warm-up activity in your OneNote class folder. That is where all of your vocabulary is, and that is where all the vocabulary videos are. And as always, I will be reviewing these problems that I went over today in our virtual class session. If you have any questions or concerns, that's the time to ask me. I can't wait to see you guys. Have a great day.